So Crystal's up here on the right-hand side. Ooh, gentlemen, let the ladies first, please. All right, you guys can get your binders out. Make sure you're filling in your learning target and your homework for today. When you're done with that, grab a pen that's not black, and your answers from last night's homework are up here. You only did 1 through 15, so don't worry about those. Okay. All right, about 1 more minute to correct your homework from last night. All right, so you are correcting on your paper with pen if you got any one of these incorrect from last night. Okay, so number seven, you should have taken 500 miles divided by 6.7 hours. Who asked for number 7? Is that what you did, Ben? Yeah. Okay, so you needed help with the division part? Yeah. Okay, so 500 divided by 6.7, okay? All right, we're going to practice teach okay. I want you to tell your neighbor, ones are going to tell twos, what is the first step you need to do before you can start doing this division problem? First step, you don't start until I say, ready? Teach. Okay. Switch. Class. Yes. 10-finger woo to Nick. Woo! Okay, Nick had some really cool hand movements. He was like, you have to take the decimal. You have to move it over here. And he got really into it, so nice job, Nick. Nick, can you tell me exactly what you were saying, though?
I was saying you have to turn 6.7 to a whole number, so you would have to move the decimal before the 7 or after.
After, yeah?
And then you would put a decimal 0, 500, and then a 0, and then move it over once.
Move it over once here.
And then put a 0.
Okay, awesome. Do we agree?
Yes.
Okay, so now you have 67 goes into 5,000, okay? So can 67 go into 5? No. Heck no. Remember, can 67 go into 50? No. Heck no. All right, can 67 go into 500? Yes. But now we have to know how many times. Oh, I know, that's the hard part. Javier?
7.
7? Let's try 7. 67 times 7. Let's see. 42, 43, 44, 45, 46. Is that what you got?
Yeah.
Javier messed up and Fabian said it's cool. 10-finger woo to Fabian. Woo! All right, 469. So subtract. I can't take from here, so I have to borrow 10 and borrow. And this guy becomes a 10, so I'm left with 1, 3. Bring down the 0. Now I have to do, oops, I didn't put my 7 here. My bad. It's, oh, darn. All right, 67 goes into 310. What do you think? 5? Everett's saying 4. Ollie's saying 4? 4? All right, let's try 4. 67 times 4, 7 times 4 is 28. Carry the 2. 24, 25, 26. Do 68, yep. Subtract there. And I have to borrow, makes that a 10. Borrow again. 4. Uh-oh. What do I do now? Okay, 2s, I want you to tell 1s what I'm supposed to do. Ready? Teach. Okay. Switch. Switch. Class. Yes. 3 times 2.
3 times 2 is 6.
Jade, tell me what you were telling Garrett.
Put a decimal after the last 0 and
Oops, here.
add a 0 after it.
And put a 0 after it. What do we call that 0? That 0 has a special name. Placeholder. 10-finger woo to Jade. Woo! Okay, So I bring this guy down, and I put my 0 here, okay? Now I have to do 67 into 420. All right, let's move on to Know It notebooks. Close up your spirals and get your Know It notebooks out. All right, so today the lesson objective, which is also your learning target for today, find equivalent ratios and identify proportions. Okay, so I want ones to tell twos what your learning target is in a very secretive voice. Okay, ready? Teach.
Okay.
Class, class, class.
Yes, yes, yes.
Now I want twos to tell ones what the learning target is with very big hand motions and act like you're really excited about learning this. Ready? Teach.
Okay.
Class, class.
Yes, yes.
Give your neighbor a high five. Okay. Here we go. All right, equivalent ratios. Everyone say yes.
Yes.
You're so excited about equivalent ratios. Ratios that name the same comparison. Ratios that name the same comparison. Okay, Martin, you got to get to our page, honey. Start filling it out. Perfect. So close it up if you've got these two. Okay, and then we're going to talk about the word proportion. An equation stating that two ratios are equivalent. An equation, oops. Stating that two ratios are equivalent. All right. So as you're finishing that definition there, let's do mirror.
Mirror.
Mirror words.
Mirror words.
Ratios
Ratios.
that name
That name.
the same
The same.
comparison.
Comparison.
Okay, I want ones to teach twos.
Okay, I want one to
Teach twos.
The definition for
Definition for
equivalent ratios.
ratio.
Teach.
Okay.
ratio.
Class, class, class.
Yes, yes, yes.
Mirror.
Mirror.
Mirror words.
Mirror words.
Proportion.
Proportion.
An equation
Equation.
stating
Stating
that two
that two
ratios
ratios
are equivalent.
are equivalent.
Twos are going to teach ones.
Twos are going to teach ones.
The definition
The definition
for proportion.
for proportion.
Teach.
Okay.
Did you guys already teach, Everett and Hunter? Did you teach already? Okay. Class.
Yes.
Class, class.
Yes, yes.
Okay. Give your neighbor a high five if they gave you a really good definition. All right. Why 3/5 and 6/10 are equivalent. Ready? Teach.
Okay.
Switch. Be careful. Careful. Be careful. Class, class.
Yes, yes.
Class, class, class.
Yes, yes, yes.
Class, class.
Yes, yes.
Okay. That was some good class yeses. I'll give you 1 point. Can't celebrate until I say go. Ready? Go.
Oh, yeah.
Nice job. All right. So, can somebody tell me their amazing explanation that their partner told them about why those two fractions are equivalent? Lena, I want to hear.
Because, like, you're just pretty much multiplying onto it, and, like, when you take it away, it's pretty much just going to be the same thing.
Multiplying onto it. Oh, when you reduce again. Is that what you mean?
Like, when you times it by 2, it just keeps adding on. But then, like, when you take it away, and when you take away that 2, then it just ends up back to 3.
Right. So I think, and correct me if I'm wrong, Lena, I think Lena's saying you can keep multiplying by any number you want, but then when you reduce 6/10 or reduce any other equivalent fraction, you're going to come back to 3/5 every time. Is that what you were saying? Okay. Great. 10-finger woo to Lena. Woo! So I want you to keep working on your own for a few more minutes. We've got about 6 minutes until the end of the period. Yeah.
So we can use 2 numbers? Because I wasn't sure how you did 2 and 3.
You can use 2 different numbers, but you have to use the same number on top and bottom on one fraction. Yeah? Make sure you're doing columns, silly. Gotta do columns. Yeah. Okay, so you're just reducing. So can you reduce 3/4 and 5/6? No, you can't. So instead of reducing, here, open your notebook. Instead of reducing, you're going to go up and multiply. Here it is. So here, so you can't divide, so you're going to do this one instead. So you're going to multiply both the numerator and denominator by any number. So pick any number to multiply both of those by.
3.
Okay? And what do you get? 9 over
12.
Okay. Okay. And how can you get 12 in the denominator for this one?
How would you do number 9? Would you just write
Not
it
divide, multiply.
like another number, like it equals? Would
Yeah.
you write like just equal or proportional to?
You can just write equals because that is this here. Let's see. This is a proportion when you have 2 that are equal. Good, 10 over 12. And 9 over 12 does not equal 10 over 12, so they're not proportional. All right, you're doing it right. If for number 7 you got not proportional, we did really great today. Give yourself a round of applause. Okay.